In this lecture, we will take a look at an important component that we will need for our car project, a motor driver. We will get an understanding of what this component is and why it is crucial to the operation of our project. We will also see how we can interface a motor driver to our Arduino to control the direction and speed of our motors. Let's get started. Here are the objectives for this lesson. By successfully completing this lecture, we will have mastered the following items. We will learn about what are motor drivers and why they are important. We will understand how motor drivers work. And lastly, we will see how we can combine our motor driver with the Arduino to programmatically control our motors. If you are ready to begin, let's drive ahead. First, let's discuss the importance of motor drivers and why they are needed for our project. The maximum power that the Arduino can provide is around 100 milliamps or 0.1 amps, whereas some motors require several amps to operate. What this means is that we typically have to provide an external additional power supply for our motors to operate, and we cannot connect the Arduino directly to our motors. A motor driver allows us to connect an external power source to supply current and voltage for our motors, and then regulates the current that is provided to the circuit. The next major point is that we need to switch the polarity of the circuit for the voltage that we apply to the motors to make them spin in the opposite direction. We can't disassemble our circuit in the middle of operation to switch the positive and negative leads to our motor terminals, but we have to do that via a mechanism known as a H-bridge transistor circuit. This allows us to use a microcontroller, the Arduino, to programmatically switch polarities, which in turn switches the outputs to the motor terminals. The motor driver has that circuitry built in and helps us to accomplish this. Next, in order to adjust motor speed, we need to incorporate some pulse width modulation. Remember, the longer the duty cycle or the time that the signal is high, the faster the motor will spin. If we have shorter duty cycles, we can slow down the speed of our motor. The motor driver circuitry coupled with the Arduino helps us to accomplish that. Finally, when motors constantly change direction and speed, because electromagnetic fields are being generated and teared down, they create a back EMF on our circuit. As the magnetic fields are dying, they interact with wires and generate small, tiny currents that go back into our circuit. If you connect your motors directly to the Arduino, this can create brownouts, and the current could mess with the operation of the Arduino board and even cause it to reset. Believe me, that has happened to me before, and it leads to an unsteady circuit. You don't want to have to deal with that. The motor driver has capacitors, diodes, and other circuitry that minimizes this for us and is invaluable for the stability of our circuit. Let's take a look at the details of how we connect the motor driver. If you look at the driver, you will see that there are 4 signal inputs that come in from the Arduino. Essentially, for a 2-motor driver, like the one illustrated here, 2 pins are associated with one motor, and another 2 pins are associated with the other motor. By applying a low voltage to one pin and a high voltage to the other pin for a particular motor, the motor will spin in one direction. If you then switch that polarity, the motor will spin in the other direction. We can accomplish this by setting signals high and low coming from the Arduino to control the polarity on these pins. There is also a ground pin on the driver, which is connected to ground, and VCC, which is connected to your external power source. Enable pins when present, can be used to enable or disable a motor. Inputs from the Arduino come in to one set of pins to control the motor, and the outputs from the driver are directly connected to the motors to relay the appropriate current and polarity of rotation. Let's take a look at the circuit diagram for our motor driver circuit. We will be controlling two motors, and for our first motor on the left, the input pins for the left motor are IA1 and IB1. IA1 is connected to pin 3 on the Arduino, and IB1 is connected to pin 5 on the Arduino. For the outputs of that motor, OA1 and OB1 are connected to the motor terminals respectively. For our second motor, or the right motor, IA2 is connected to pin 6 on the Arduino, and IB2 is connected to pin 9 on the Arduino. The outputs from the motor driver board, OA2 and OB2, will be connected directly to the terminals of your right motor. The ground pin on the motor driver board is connected to the ground on Arduino, and the VCC pin on the motor driver is connected to the positive of your 6-volt external power source. That is essentially the wiring for your circuit. Okay, now I'm going to wire up the circuit for our motor drivers to demonstrate how they work. So what I'll use is the two motors from our car kit. So I'll be connecting to those motors to use them for the demonstration. And what we will have to do for these motors is, notice there are no connecting wires here at the motor pins. So we'd have to actually I have 4 strips of wire here that this is just plain wire that will connect to the ends, and that will complete the connection to the motor itself, and from there we could connect the other ends to the motor driver. So that's something we'd have to do first before we get going. And also here is the motor driver itself. As you can see, there are a couple of pins on there for the outputs of the motors. So here at the top, this would be the output pins to one motor, and this is the output pins to the second motor. And here we have VCC, we have ground. VCC would actually go to the external power source. We have the ground pin, and then we have the input B1 and A1, right? Those are the first 2 pins for the first motor. And then we have input B2 and A2. Those are the second pins for the second motor. So very simple circuit. Here's our motor driver, very small. To make things a little easier to wire up, we have a female to male connector pin. So if you'd notice on one end, it's a female that can actually plug straight into the right angle connector on our motor driver, and on the other end is a male pin, and that can connect to our breadboard or directly to the Arduino. So if you have these female to male connector wires, that will make things a lot easier in wiring up your circuit. So first, let's go ahead and attach these wires to the motors so that we can have a connection from the motor to the motor driver. Okay, so I'm just finishing up connecting the wires to the motor. So this is just a temporary sort of connection. So again, I'm taking the wire and I'm passing it through the actual hole of the connector to the motor, and I'm just going to bend the wire back. And this is just a temporary connection. Of course, ideally we should solder this on, and also a tip is to solder a capacitor between the motor terminals, a 0.1 microfarad capacitor, and this helps with back EMF and helping to reduce noise on your circuit and so on. So generally a 0.1 microfarad capacitor soldered between the motor pins would help smooth out any irregularities in the voltage signal. But for now, we're just going to temporarily connect these wires for the purposes of demonstrating how our motor driver works. Now we're going to connect the female to male pins on our motor driver. So I'll just go ahead and do that. And 6. Okay, so now those are all connected, and it makes it easy to plug these into the actual circuit. So first, from the input pins of the connectors, we have IB1 goes to pin 5 on your Arduino. Then we have IA1 goes to pin 3. IA2 goes to pin 6. That's the last wire here. And IB2 goes to pin 9. Okay, so those are the inputs. Now we have the ground pin. I'm just going to connect that to the ground rail on the breadboard, and the VCC goes to the 5-volt rail. Before we forget, let's connect the ground and 5-volt connections from the breadboard itself. So first the ground connection, and then we're going to do the 5-volt connection to the 5-volt rail. Okay, so that is essentially those connections there from the motor driver to the Arduino. Now we're going to connect from the outputs of the motor driver to our respective motors. So our motor A, or our left motor, the outputs are going to be this OA1 and OB1. So this is, at the top here is going to be our left motor. So let's connect that there. And the way that these work, essentially, you put the wire in to the connector, and you actually just screw the wire down to secure it in place. So that's exactly what we'll do. Alright, so that's securely in place there, and similarly we will do that for the other wire. With that, our motors are connected. When we're working with motors, we would need to provide an additional external power source, since the Arduino cannot provide power to drive the motors on its own. So what we can do is have a battery holder. So this is a 4 AA battery holder, and it should provide about 6 volts when the 4 batteries are in here, the 1.5 volts each. And at the end, this is pretty handy in that there's a female connector at the end, which makes it easy to plug into a circuit. So this is already attached on here. Also, it's more compact than the battery holder that came with the kit. So this is what I'll recommend to use for your external power source. So I'll just put some batteries in here, 4 1.5 batteries. There's 1, 2, 3, and 4. So those fit nicely snug in there. And we can actually test the voltage that comes out of here. So I'm gonna just take a couple of male pins. Here's my voltmeter. Alright, so I'm going to put this on. And with the battery, I'm going to measure the actual voltage on the battery. So I'll go ahead and do that. Alright, so we'll touch those there. Alright, and if you notice, it's about 6.3 volts. So we're getting a little more than 6 volts from our battery pack, so that it should be enough to drive our motors. So now we have to connect this battery to our circuit to drive our motors. And the VCC actually, earlier I had said that it would go to the 5-volt rail. The VCC on here is actually goes to the positive of your external power source. So it's going to go into that red connection here where the red wire is, and the black is going to be grounded. So from the black here of our power source, we can go to ground on our circuit. Alright, so I'm not going to put this in here yet. When we actually upload the code, then I'll connect this to our motors. So we'll do that a little later on. The last thing that we need to do before we upload the code to our circuit, to tell the direction of spin on the motors, we're going to attach the wheels onto the actual ends. To make things easier to see the direction of spin on the wheels, I made a couple of labels, a white label for left and a blue label for right, and I'll stick those onto the ends of the wheel. So I'll just apply some tape here. Alright, so if you remember, our left wheel is the top wheel from our motor driver. That goes to this particular wheel here, so I'm going to stick that left on so we can tell the direction of rotation. And the other one would be our right wheel. That actually goes from the bottom of the motor driver. This is the other wheel. So I'm going to stick that on here. Okay. And now our circuit and our motor driver is all connected, and we're going to proceed to upload the code to test everything out.